Hello guys, am I audible? Very good. Hi Hetvi Mehta. Hello, how are you? So, my dear friends, today we are going to talk about the fourth lecture of current electricity. Means we are going to discuss today Kirchhoff's law, KVL and KCL. Okay, mainly today we will discuss KVL and KCL, Kirchhoff's voltage law and Kirchhoff's current law. Yeah, I'm also good, Hetvi. I'm also good. Yes. So let's continue, my dear friends. So today's lecture is very important because without Kirchhoff's laws, you cannot solve current electricity properly, right? So to learn the current electricity properly, you must need to learn the Kirchhoff's current law and voltage law. Okay. So let us start, my dear friends. At first, I would like to welcome you all. Welcome to Unacademy. Unacademy is India's largest learning platform where you can prepare for the various competitive exams with the help of the top educators of the country, with quality content and great learning experience. Yes. So current electricity, KVL, KCL, today's topic. Now I'll talk about myself. My name is Rahul Dagariya. I have been teaching physics since 5 years in the various reputed institutions of India. Till now, I have mentored to the thousands of aspirants of NEET and IIT, and now I am available here to help the students of the country to learn the concepts of physics for NEET UG with the best notes and best examples. So if you did not download the Unacademy app yet, please go to Play Store and download it. Next, my dear friends, I'll talk about the Unacademy subscriptions. So you can see Unacademy subscriptions are available for 1 month, 3 months, 6 months, 12 months, and all right. Yeah. So you can see Plus subscription and Iconic subscription. We are having two types of subscription for you. So for in Plus subscription, what you are going to get? You know, so you are getting the daily live classes, just like special classes. You will get the all classes there live. Chat, you can chat with the educator. You can participate in any discussion. You can ask your doubt, and you can participate in the answer polls. Live test and quizzes are available there for you, my dear friends. Yes. So I have missed previous lectures due to personal issue. I'll watch it after this lecture. Ah, okay, my dear, no problem. Yeah, you can watch it. Okay. Structured courses, my dear friends. You are getting all three subjects: physics, chemistry, and biology. That too by the India's top educators. Unlimited access, my dear friends. You are going to get the unlimited access to the live and recorded courses, my dear friends. Okay. If you miss the live class, you can watch its recording. Iconic subscription, next very important thing, the Iconic subscription. You are getting all the plus benefits here. Okay. But apart from that, you will get a personal coach. My dear friends, the personal coach will guide you one on one at each and every moment to prepare the strategy for your NEET exam. Next, test analysis. My dear friend, test analysis, amazing feature it is. You might have attended some quizzes, right? Like that, test and all features are there. Test series is also there, my dear. And you will get its in-depth analysis, means where you are lying and how much you are like how many concepts you learn properly, how many concepts you don't know properly, everything you'll get there. Next, study planner, my dear friends. You will get the complete guidelines and the study plan for your and strategy for your exam, my dear friends. You will get the weekly reviews also. Okay. And all plus benefits already you are getting. So my dear friends, let us compare this both plus benefits and iconic benefits. है ना? So, on Plus subscription, you are getting India's best educators, interactive live classes, structured courses and PDFs, and live tests and quizzes. On Iconic subscription, you are getting all the Plus benefits, but apart from that, you are getting a personal coach, study planner, expert guidance, and test analysis. Okay. Next, I'll talk about the Iconic subscription fee. This fee is only for 2 days, my dear. 21st, 22nd, and 23rd. From 24th, it is going to increase. From 24th, this fee is going to increase, and there will be 6 months subscription also for Iconic. Okay. So 12 month subscription you'll get for 45,000 rupees. 24 month subscription you'll get for 61,000 rupees. But if you are using my code Rahul T, then you'll get the 10% discount, and you need to pay 40,500 rupees for 12 months and 54,900 rupees for 24 months. Okay, my dear. Hi, Kushi. How are you? Now, NEET UG subscription, my dear friends. If you want to get NEET UG subscription, get it quickly within 2 days, because on 3rd, I mean 24th, the prices are going to increase. So it is available for 1 month, 3 months, 6 months, 12 months, and 24 months. 1 month fee is 6,000 using my code Rahul D. You need to pay 5,400 rupees, means 10% discount you are going to get. 24 6 months subscription you will get for 24,000 rupees, but using my code you'll get it for 21,600 rupees. 12 month subscription is of 30,000 rupees, but using my code Rahul T you will get it for 27,000 rupees. And 24 month subscription, actually it is of 36,000 rupees and equivalent to 6 months fee. Yeah, so that you will get for 32,400 rupees only, but don't forget to use my code Rahul T. Okay. Yes. So now I'll talk about all the benefits of plus you are getting, right? Extra benefits also you are getting. But now today's topic is current electricity lecture number 4. Means we will discuss the Kirchhoff's laws today. Kirchhoff's laws. Okay. So very easy, but very important topic it is. Okay. Learn carefully. I'll explain you very well. Okay. I'll try my best so that you can learn it properly. Okay. I'm also good, Kushi. So, my dear friends, at first, let us talk about Kirchhoff's law. Actually, Kirchhoff explained two laws. He gave two laws. Okay, one is called we can say junction law, or we can say current law. KCL, Kirchhoff's current law, and another is Kirchhoff's voltage law. KVL. Okay, that is called loop law also. Yeah. So let us talk about it. At first, Kirchhoff's current law. Okay. Yeah, why Kirchhoff gave these two laws? Kirchhoff gave these two laws just because we can solve the circuits. Okay, so we can solve the circuits easily with the help of Kirchhoff's laws. Yes. So at first, this law is based on the law of conservation of charges. My dear friends, as I told ki in a circuit, charges will always conserved, right? No charges are added, nor no charges are destroyed. Okay, so simply speaking, my dear, he will say the charges will remain conserved. Okay. So for a circuit, charges are remain conserved. So this thing you need to remember. It is based on law of conservation of charges. Okay. Next, because such type of statements are you may get in the options out of four options. Which of the following is the correct option? So you may get such type of option there. Ki Kirchhoff's current law is based on conservation of charges. So obviously that's a correct statement. Next, yeah. So what it states that the all algebraic sum of currents meeting at a point of circuit is zero. Okay. Let's say there is a circuit and there is a point. Let's say a junction is there. A junction is there. Okay. So I am saying so many wires are there. So I'll say I1, I2, I3. You know? Yeah. I4, and I'm saying this is I5, and this is I6, and this is I7, let's say. Okay, so what I'll do, all currents coming in I'll take positive, and current going out from the junction, going away from the junction, I'll take negative. Okay, so what I'll get, I1 plus, I2 plus, I3 plus, I4 plus, no, here minus, I5 minus, because it is going away from the junction, right? Yeah, here you will write I6, here you will get I7, and sum of this all should be equal to 0. So simply speaking, my dear friends, net current at the junction is always 0. Okay, so you just need to either you consider current coming in negative and going out positive, or you consider current coming in positive, going out negative. It's your choice. It is completely your choice. In any condition, it is correct only. Okay, you just remember one thing is sum of current at the junction, you know, that will be 0. Means total current coming in will be equal to total current going out. That's all, my dear friends. Very good. Yes. So I will say total current coming in is equals to total current going out. That's all. Yes. So we have done with this. So let's move ahead. This is the question in front of you. Find the relation between I1, I2, I3, I4, I5 and I6. Come on. So I am giving you four options. A, B, C, D. A, B, C, D, four options are there for you. First, I1 plus, I2 plus, I3 plus, I4 plus, I5 plus I6 is equals to 0. Next is I1 minus I2 plus I3 minus I4 plus I5 minus I6 is equals to 0. Okay. Next, I1 plus I2 minus I3 minus I4 plus I5 plus I6 is equals to 0. Okay. Yeah. And last sum of, yeah. So I1 plus I2 minus I3 plus I4 minus I5 plus I6 is equals to 0. Which of the following option is correct? Come on. Choose the correct answer. Which of the following relation is correct? Right? Which of the following relation is correct? A, B, C, D. Yes. So Rajni gave the answer I1 plus I2 plus I. Yeah, very good. C option. Very good, Hetri. Very good, Rajni. C option is the correct answer. Very nice. All currents coming in, I have taken positive, and going out, I have taken negative. So I4 is going out, and I3 is going out. So both are negative, else all are positive. So that's all. This is the answer. C option. Very good. Next, this is the question in front of you. Okay, this is the question in front of you. But now I would like to tell you one thing. Listen, whenever you are getting such type of question, I told you at first, listen, you use nodal analysis method that I explained you in the last class. Nodal analysis method. Okay, nodal analysis method. So what is the question is, find the current in each wire. How many wires are there? So you'll say ki, I'll consider any one junction. So I'll get what current in each branch. So I am saying ki FE1, okay, DE second, and BE third. These are three branches are connected at point E. Okay. So we just need to find the current in this all three branches. Okay. So use nodal analysis method. Use nodal analysis method means find the simplest point. Find the simplest point where you can consider potential is zero. Okay, so I can see here ABC. This is a branch where I cannot find any resistance, no battery, nothing. So I'll consider here is zero, here also zero, here is also zero. So this I am considering zero potential. Okay, A is reference point, zero potential. B is reference point, zero potential. C is reference point, zero potential. Okay, now let's move this side. So this is minus, this is plus. Here I will get 10 volt. Here I'll get 10 volt. No problem at all. I got 10 volt. Okay. Now this is 0. है ना? Now go up. So here you will get 30 volt. At this point you are getting 30 volt. No problem. You got 30 volt here. And at E, we don't know. Let us consider voltage at E is X. Voltage at E is X. We don't know, but we are considering that is X so that we can find its value. Yeah, you can see here. C, it is having 0 voltage. Go up, go up, go up. Here you will say what? Ki our cell is in opposite polarity. Here is negative terminal. So obviously potential will be here minus 14. Minus 14. Okay. These things I explained you in the last class, but once again you see what's going on. Listen what I mean to say. Listen. Yeah, I told you one thing. Listen. If I am writing like this, I am saying this is point A, this is point B. Potential of point B is 10 volt and battery is of 100 volt. Okay. So this is negative, this is positive. So as you will go this side, move this side. So you will say here positive terminal means potential will be added. So here you will get potential of A 110 volt. Okay. Remember that. Next, if you are getting here 10 volt, okay, and cell is added like this. So now this is of 5 volt. Okay. And here is point A. So B is having potential 10 volt. Cell is added like this. So go this side. You need to find potential at A. So you are going. This is 10 volt. Here 10 volt. Here you come. What will happen? Cell is in opposite polarity. This is negative. So this is negative means you will write here what? Minus 5 volt. So 10 minus 5 you will get 5 volt. Right? 10 minus 5 you are getting VA is equals to 5 volt. That's all. Answer. Okay, it is not answer of this question. I am just explaining how to use this cell. Okay, how to use the polarity of the cell. Okay, so just I am explaining that, nothing else. Yes. So let us solve this particular question which is given in the diagram. So we are going to solve this particular question. Okay. Yeah. How to solve such type of question? We will use Kirchhoff's junction law. Nodal analysis we have used. Now we are going to use Kirchhoff's junction law only. Okay. So I am saying, my dear, listen. You understand both the laws. Okay. Whatever you feel easy, you can use that. No problem. Yeah. So just consider कि current, है ना? Current is going out from the E. We don't know what is the direction of current. We don't know. We don't know. We are just considering कि current is going out from the E in all directions. So I will say this is I1. Okay, no problem. This side current is going away from the E junction, that is I2, no problem. Now here current is going away from the junction, right? So that is what I3 current. Okay. Next, I am saying in all these three situations, current is going away from the junction. So we know only one thing. What we know? What we know? We know that at junction, sum of all currents is 0. So I will say at junction E, at junction E. So I1 plus I2 plus I3 is equals to 0. Why I am doing like that? Because I have considered E is having X potential that I don't know. Okay. And in all three branches, current is going away. Actual we will get. Okay. Kavya tomorrow. Tomorrow is the wave optics. Okay. Today I could not take, my dear. I had some other work, so tomorrow will be there. Okay, just 2 lectures more for wave optics. We'll finish it tomorrow. Tomorrow 5:30 p.m. Okay, time I am telling you, tomorrow 5:30 p.m. at any cost. Okay, it will not be changed. So my dear friends, I1 plus I2 plus I3 is equals to 0. Okay, now what to do? We know current always flows from higher potential to lower potential. So I am saying E to F, है ना? E to D, E to B, it is flowing. Means I am saying E is having maximum potential. So higher potential minus lower potential. So you'll write X minus F is having 10 potential. So you can write what? Delta V upon R. V is equals to, you know that V is equals to IR. So I is equals to V upon R. V is the potential difference. So in this first branch, and not EF branch, you can see I1. I1 is what? X minus 10 divide by resistance is 1 ohm. Okay. Now next I2. I2 means this ED branch. So here you can write what? Potential is X minus of minus 14 divide by resistance is 2 ohm. Okay. Yes. Next, my dear, third one. Third one, you can see the branch is EB. In EB branch, current is going downward away from the junction. So you will write X here. Now you can see here along this, yeah, across this resistance, what is the voltage drop? You can say at E voltage is X, and after this resistance you are having 30 volt. So you'll write here 30 volt. So X minus 30. Okay, X minus 30 you will write. Oh my, yeah. Divide by its resistance is 2 ohm, and sum of this all should be 0. So just solve it. What you will get? So X, yeah. So take LCM and solve it. So you are directly getting what? 4x. What you are getting? 4x. That is equals to 36. Okay. So x you are getting 9 volt. Hey guys, you got the potential. Kavya, you are saying so change that daily take class. Okay, my dear Kavya. So my dear, are you getting? Yes, yes, yes. Did you understand? X is equals to 9 volt means we got the potential of point E. If someone is asking what is the potential of E point, so you will say what? That is equal to 9 volt. Now what is the current in first branch? So I1. I1 will be equal to what? X minus 10 upon 1. X minus 10 upon 1. Use this. So 9 minus 10. 9 minus 10 upon 1. So you are getting minus 1 ampere. Minus 1 ampere, what is the meaning of that? If you are getting current negative, it means whatever direction you have considered for the current, it is just opposite of that. Okay. So you have considered direction of current is E to F, but actual it is F to E. That's why it is coming negative. So no worries. You will just write what direction of current is F to E, and that is 1 ampere. So I will say 1 ampere. Okay, and that is F to E. F to E. That's all. So this is the first current. Now current in the second branch. So what to do? So I am writing here. That is X plus 14 divided by 2. So 9 plus 14 divided by 2. Okay. So this is what? 23 divided by 2 means 11.5 ampere. 11.5 ampere. That is 11.5 ampere. Hey guys, you are getting positive sign. You are getting positive sign. Means current is flowing from E to D. That is correct. Current is flowing from E to D. Higher potential to lower potential. 9 to minus 14. So that direction is correct only. You are getting 11.5. Okay. Right. Did you get it? Very good. Next. Third, E to B. E to B, I am saying ki x minus 30. So you will write what? Minus 21 by 2. You are getting minus 10.5. Minus 10.5, you are getting the current. Okay. So minus 10.5 means current direction we have considered E to B, but actual may it is in which direction? It is B to E. Right? Why? Because it is negative. So that's all. We got the answers. Okay. I hope you understood. Right? I hope you got this. Right? So simply speaking, whatever we have considered, I1 we got what? We got 1 ampere. From which direction to which direction? Sorry, I forgot the value. What was that? Yeah, 1 ampere only, and that was from E to F. F to E. F to E. Okay. Next, I2. I2 we got in this direction. That is the 11.5 ampere, and that was the correct direction E to D. No problem. Next, I3 third current we got, that was B to E. B to E and 10.5. So 10.5 ampere B to E. Okay. That's all we have done. Okay, Hetvi is asking, sir, explain it with the voltage law. Yes, Hetvi, I'll explain the same with the voltage law. Okay, after some time. Let me introduce voltage law first. After that, I'll explain. Okay, don't worry. From both, you will get the same answer. This was nodal analysis method, right? I'll explain the same with the help of Kirchhoff's voltage law. Yes. So just a minute. Let me explain the Kirchhoff's voltage law first. Okay. Kirchhoff's voltage law, or it is also called loop law. Okay. So listen. Very important thing I am explaining now. It's most important. So the algebraic sum of all the potential differences across a closed loop is zero. है ना? Remember, the algebraic sum of potential differences across a closed loop is zero. I'll explain you properly. You will understand today. Okay. Next, I can say कि voltage can be given by what? V, or we can say IR. V is equals to IR, right? So IR also will represent a voltage. Means voltage drop across a resistance is I into R, current into resistance. Okay. Yes. So it is just simple. A diagram is shown in front of you. Okay. So what to do? What to do in Kirchhoff's voltage law? Listen. Listen, my dear. I am explaining a very important thing. Let's say I have a battery like this. Okay. I have resistance like this. I have another battery like this. No problem. And I have another resistance like this. This is A, this is B, this is C, and this is D point. I am saying this is having potential E1, this is having potential E2. This is resistance R1, this is resistance R2. Now how to solve it? How to solve such type of circuit? So listen, I am applying Kirchhoff's voltage law. At first, Kirchhoff's voltage law or loop law is applicable for a loop, closed loop. Okay? Yes. So I am explaining this first. Let us consider the direction of current. It is your choice. It is your choice in which direction you are taking current. So I am taking current in rightward direction. So I'll consider current is like this. I current. Okay, no problem. I have considered. Okay. Current is entering in the resistance. So that will be always high potential, and current coming out, that will be low potential. Always mark like this. Okay. Still, this big one is always positive. This small one negative. This is positive. This is negative. Now I am saying current is coming like this. Like this, current will enter here. So this is positive. This is negative. Okay. Current always flows from higher potential to lower potential in a resistance. Okay. So always mark positive sign where current is entering and negative sign where current is coming out. Okay. Now how to solve the voltage law? How to solve the voltage law? Okay. Listen. Very important. Listen, my dear. Always you consider a direction either clockwise or anti-clockwise. It is your choice. It is your choice. Start from any point. Start from any point. So I am starting from point A and I'll move this direction, clockwise direction. Okay. Miss, this clockwise is direction of observation. Clockwise is direction of observation. Remember that. Now, as you are moving clockwise direction, always take the second sign across a particular element. Second sign means you are entering and coming out. So always take the sign where the current is coming out. So listen, I'm starting from point A, I'm moving like this. Okay, no problem. So here first sign is negative, second sign is positive. So I will take plus sign. I'll take second means plus sign. Second plate sign always we will adapt. So you will write what? Plus E1, no problem. Now move ahead, move ahead. So potential drop across this resistance V is equals to IR1. IR1. है ना? So you will write IR1, no problem. Which sign you will write? So you will say ki second sign. So first sign, current is entering here, positive sign is here. Current coming out, there is negative sign. So you will adapt always this second sign. So adapt this minus sign you will write. Okay. Now move ahead. You will come here. You are getting here. First sign is positive and second sign is negative. So you will end up second sign. So minus E1. Okay. Come here. Yeah, current is entering from positive, coming out of negative. So you will say what? Negative sign you will adapt means minus I R2. So you are getting finally E1 minus E2. This is E2, sorry. E1 minus E2 is equals to I into R1 plus R2. So final answer current you are getting what? E1 minus E2 divided by R1 plus R2. That's all. Okay. Got it? Is it like is this explanation good? Yes. Did you understand? Did you understand? At first, you consider the current in the circuit. Okay, you have considered. After that, you consider the direction of observation. Direction of observation. Okay. Yeah. You need to adapt the second sign always. Second sign. The current is entering from the positive and coming out of negative. Right. If you are observing in the same direction of current, so you need to take negative. Okay. Now reverse I am solving. Now I am solving in reverse direction. Let's say we are going to observe in anti-clockwise. If I will observe anti-clockwise, what will happen? Let's see. So now I am changing the direction of current. So let us start from A point. Let us start from A point. So I'll move like this. So I am observing in this direction. So I am going like this. Current is moving in opposite direction. Current is coming like this. Already shown. Direction of current is clockwise, but you are observing anti-clockwise. So you will take always second sign. So come here to here. So you will get positive. So plus I don't know why this problem is here you will write plus I R2, no problem. Now come this side, here minus sign, here plus sign, so you will write plus. So plus E2, no problem. Now come here. Here you are coming, so second sign is positive. So take this positive plus I R1. Okay. Now come this side. So here you are coming, here is negative sign, second sign is negative. So you will take minus E1 is equals to 0. Let us solve this. What you are going to get? So you are getting I is equals to what? E1 minus E2 divided by R1 plus R2. Basically, you are getting same sign. Basically, you are getting same time. Hi, Afra. Yeah. So I hope you got this. If you got this, please give thumbs up, my dear friends. Please give thumbs up. So this is the basic thing I wanted to explain you, my dear. Right. So these are all things I have written. You can see the you can see the diagram. You can see the diagram. In the diagram, plus minus signs means direction of current is already given. Always flows from positive to negative. So how? You are observing clockwise direction. You are observing clockwise direction. So what you will write? So let's say we are starting from this point. Okay. So I am going like this, plus minus. Second sign is negative. So minus V1. Okay. Now come here, plus minus. So minus V2. Now come this side. So minus plus plus sign. So plus V3. Now come here, plus minus. So minus V4 is equals to 0. That's all. So this is the answer. This is the equation. Okay. Right. That's all, my dear friends. So this was all about voltage law. Just very simple instruction I gave you. Okay. Always you consider the direction of current first. Okay. The point where current is entering, that is positive terminal of resistance. The point where resistance is coming out, that is negative terminal of resistance. Okay. The long line of cell, that is positive always, and that small line is always shorter line is always negative terminal, right? Yeah. Now take the direction of your observation. Okay, right? So you will always adapt the second sign. That's all, my dear friends. I hope you got this, right? I hope you got this. Now let us solve this question with the help of Kirchhoff's law, Kirchhoff's voltage law. Okay. So Hetvi, we are solving this question with the help of Kirchhoff's voltage law, loop law. Okay. Yes. So listen, my dear, how to solve this? Yeah, so I am taking this black ink. Yes. So now I am considering, let's say current is moving like this. This is I1 current. Okay, no problem. I'm considering like this. I don't know what is the direction of current, but I'm considering I1 is like this. Okay. Now I am considering I2 is like that. You can consider in any direction, no problem. You'll get the same answer. I2 you are getting like this. Okay. Now you come here. I1 it is going like this. So you can say what? I2 is coming here. This is I2 and I1 is going like this. I1 is going like this. So what you will say? What you will say? So simply you can say what? I2 is in upward direction. I1 is coming out. Hai na? Yeah, here you can write what? I1 minus I2 you can write. Hai na? Here you can write what? This is I1. This is I2. So I1 is coming in and I2 is going out. So you can write here what? Here you can write I1 minus I2. Your choice. Okay. I1 minus I2 you can write here. That's all. So I have written like this. Okay, no problem. I1 is coming here and I2 is going there. So I will write in the middle branch current will be I1 minus I2. Now you have two loops. You have two loops. This is first loop, loop number one. Now this is second loop, loop number two. You consider any direction that is okay. I am considering clockwise for both. So this is first loop. This is second loop. Okay. So let us solve for both the loops. Let us solve for both the loops. How can we solve? So listen, my dear. Listen, how can we solve? So I can write for the first loop. First loop. Okay. Right? Start from A point, let's say. So from A we are moving, you know. So in the direction of current, we will take the sign positive and another is negative. Okay. So actually this is a small process. Just I am explaining. That's why it is taking time. You know? So this is negative. This is positive. Here current is entering. This is positive. This is negative. No problem. Here current is entering. Positive sign, negative sign. Cell. Positive, negative. No problem. Here also current is entering here. So this is positive. This is negative and this is negative terminal, positive terminal. That's all. Now we can solve it easily, very easily. Okay. Yes. So now solve it. First loop, you know, from point A I am starting. So let's come up. You are getting plus 10, you know, because second plate is positive. So plus 10. Now move ahead. Entering into positive, coming out of negative. So I1 into R, that will be negative. Why? Because second sign is negative here. Okay. Now come to this middle branch. You know, you are taking this loop, right? Small loop. So now I1 minus I2 into R. Second sign is negative. So you'll write minus of I1 minus I2 into R. R is 2 ohm, right? R is 2 ohm. Yeah. So sum of this all should be what? 0. Now this cell is remaining. You know? So current is entering I1 minus I2 is entering to plus 30 and coming out of minus 30. So you'll add up second plate means minus 30. That will be equal to 0. Okay. Now solve this. Now solve this. What you will get? So if you solve this, you will get I1. So you can write 2I1. You know? So 2 and 3I1. So you are getting 3I1, okay, plus 2I2 is equals to 20. If you simplify this, you are getting this equation. 3I1 plus 2I2 is equals to 20. Now, let us observe the second loop because two variables, so two equations are needed. So second loop, let us observe. You know? So if I will observe second loop, start from E point. Start from E point. So I am writing here minus I2 into R. So I will write here minus I2. I2 means what? Minus of 2. Yeah. So I2 into 2. Now let us come here plus plate. So plus 14 you will write. Now come here. No problem. Now come to this middle branch. You know, come to this middle branch. So second plate. Minus, from minus it is entering and from plus is the second plate. So plus 30 you will write. No problem. Now 2 ampere. So current is I1 minus I2. You know? So you will write second plate is positive. So plus I1 minus I2 into it is 2 ohm resistance. That will be equal to 0. So if you will solve this, what you will get? If you will solve this, what you will get? Yes. Come on. Yeah. So this is 2I2 and this is 2. So I can say 4I2 that is negative. So I1 minus 4I2 I can write here. Okay. Yes. So that's all, my dear friends. So quickly we can write here what? I1. Yeah. So yeah. So you can write the equation here and you can solve, right? So just simplify this, solve first and second equation, you will get the answer. Okay. From KVL also you'll get the answer, my dear friends. From KVL also you'll get the answer. Why to worry about that? Definitely you'll get the answer. Okay. Listen. We have observed this. You can see here minus 2i2 we have written, no problem. Come this side. So here you will write what? Plus 14 we have written. Come here. So here you will write plus 30 you have written. Okay, no problem. Now what next? Now what next? Listen, my dear. Listen, listen. Here is one problem. Why you are not getting the answer? Why you are not getting the answer? Its reason is here you will write negative sign. What? Here you will write negative sign. Why negative? Why negative? Its reason is current, है ना? Current is coming down and you are going up. So for second loop, है ना? For second loop, you need to consider different sign convention, है ना? So for second loop, you have to consider here, right? So this is positive, this is negative, right? So anyhow, it's correct. Yeah. So just yeah. Anyhow, you'll get the answer from here. Don't worry, we have written the correct answer only. Just it is plus only. Sorry, I have just observed wrong now, right now. But whatever we have done, that's correct only. Okay. You just solve these two equation, you'll get the answer. Okay. I1 you will get, I2 you will get, then take its reference, you'll get I3 also. Okay. Yes. So that's all. Definitely you'll get the answer from here. Okay. That's all, my dear friends. You need to solve it. You will get the answer. Got it, my dear friends? Yes. Did you get it? No. What happened, Rajni? Something is wrong? Something is wrong? Listen, my dear. You just observe both the loops separately. You know? Both the loops separately. Listen. For first loop, we have written the equation. For second loop, again, let us write the equation. Okay. I am saying I2 was going like this. Okay. I2 is going like this. Here, current is coming like this. That is I1 minus I2. No problem with this. Okay. You have considered this is positive, this is negative. No problem because you are observing like this. Okay. Now, here is negative, here is positive. Okay. No problem. Now, come here. Negative, here positive. No problem. Here you can see current is coming down. So you will write here what? Here you will write negative sign. Here you will write positive sign. Okay. So in your direction of the observation, you will take always the sign of second plate. You will take sign of second plate. Okay. Right. Definitely you will get the answer from KVL also, my dear. That's all. Okay. So I am writing equation for this again, my dear. Let us see. From E point I am starting. So you will write what? 2i2, but that will be negative. Why? Because second plate is negative. Plus 14. Okay. Now come here. 30. From 30 you are observing. So first plate is negative, second is positive. So you'll write plus 30. No problem. Now move upward. Now move upward. What will happen? What will happen? Yes, come on. What will happen? Here you can write negative sign here and here is positive sign. So you can write plus 2 I1 minus I2. Okay. So just is equals to 0. Previous and this both you solve and you'll get the answer. That's all, my dear. Very good, Hetvi. Hetvi का आ रहा है. Definitely खुशी आपने कुछ mistake किया होगा. You made some silly error, so you'll get the answer. Okay. Solve it again after the class. You'll get the answer. Okay. Don't worry. We have more examples for you. No need to worry about that. Yes. Solve this question. Can you solve this? Find the potential at point A. Find the potential at point A. At point A, you need to find the potential. Can you solve it? Yes. Just consider like this. Current is always flowing from higher to lower potential, right? So consider potential at point A is X. Okay, I have considered. I don't know which is higher, which is lower. I don't know. Hai na? So consider in all branches current is coming towards the center. Just current is going away from the center. In all the branches, current is going away from the center. You consider like that. Okay, so I have considered this is I1, this is I2, this is I3, and this is I4. Okay, no problem. So you can write what? I1 plus I2 plus I3 plus I4. Sum of this all will be what? 0. Okay. Yes. Are you getting? Now how you will write I1? How you will write I1? So I1 we can write like this. I1. Higher potential minus lower potential. So move from point A to higher potential is X. Okay. Now move here. So here is X. So here I am saying keep potential will decrease by minus 15 and here is 20. So you will write X minus 15 minus 20 है ना. I is equals to V upon R, right? So upon R is 2 ohm. Okay, we have written like this. Yes, yes. Now second, I2 let us consider here this branch. This branch is having current I2. So how to solve that? So you will say कि you are going from center. So X, okay, minus what you will write here? This is plus, this is minus. So minus IR2 है ना? Correct, correct, correct. Can you do it? X, here you will come, 5 will decrease, right? Are you getting? Listen, my dear. Here you are coming. So here what will happen? The potential will decrease by 5, है ना? And here is 50. So here you will write X minus 5 minus of minus 50 divide by total resistance, that is 2 ohm. This is I2 current. Now let us write I3 current. I3 is what? This is the branch down. This branch is I3. Okay. Now you go away from the center. So X minus of minus 30. है ना? You are just subtracting the potential. That's all. Nothing else. है ना? Center potential minus whatever potential is there in the circuit. Maybe there is cell or the end potential, right? So just take potential difference divide by resistance. So resistance here in this branch, that is 1 ohm. Okay. And now I4, for I4 you will write this branch, right? So come from here to here. So as you come this side, this is X4, here 20 volt is decreasing. So minus 20 and here minus 10. X minus 20 minus 10 divide by its resistance is 1 ohm. Okay. Just put this all value, you'll get the value of X. Just put this all value in this particular equation, you'll get the value of X. Did you understand? If you did not understand, I'll write the equation and explain you properly. If you understood, please give thumbs up. If you have doubt, say doubt. Come on, come on, come on. If you got it, please give thumbs up. If you did not get, please ask me again so that I can explain it another way. Other way. Other method. Are you getting? Yes, yes, yes. Okay, so I am explaining this again with the help of second method. Listen. This is 20 volt. Okay. This is 2 ohm. Yeah, very good, Hetvi. So I'm just giving idea. I'm just giving idea, not solving completely because we have already solved it. So I1 plus I2 plus I3 plus I4, just add this all, you will get the value of X. Right? And what value of X you are getting? I have written it. You are getting value of X minus 5 by 3 volt. Okay, X is equals to minus 5 by 3 volt you are getting. So minus of 5 by 3 volt you are getting. Okay. Yes. How to solve that? Let's say this is X. This is 15 volt. It is written. I am considering current always flows from higher to lower. So I am writing I1. This I have considered I1 is like this. Okay. So how to do it? So start from X. Start from X. So you will write X. Now you are moving upward. So first is positive, second is negative. So minus 15. Now move like this. So current is moving in this direction. This is positive. This is negative. So you will take minus I1 into 2. Now the final that is 20. So that will be equal to 20. That will be equal to 20. है ना? Yeah, you can write minus 20 is equals to 0, right? So here you will write is equals to 20. That's all. Yes. So now solve this. What you are getting? So X minus 15 minus 20 is equals to I2 divided by I1 divided by 2. Can you see? It is same as I1 we have written. X minus 15 minus 20 divided by 2. This is I1, right? So like that you can solve. Just like Kirchhoff's law you can use. Answer is minus 5 by 3 volt you are getting. Okay. X potential of this point A, that is minus 5 by 3 volt. Okay, my dear friends, did you get it? Yes, very good. Right. So for first branch we have like proven it. Now let us talk about the second branch. Any other branch also I am discussing, in which cell polarity is just opposite. So that you can understand in a proper way. You know? So one more branch I am explaining, my dear, if you are having doubt. I am giving you second method to solve the same question. Second method, my dear. Okay. First method I explained in the white diagram. Second method I am explaining in this yellow ink. Okay. So my dear, I am saying let us observe this I2 early branch. No. Let us observe I2 branch. Let us observe. Okay. Yes. So you can say X current is moving in this direction. So positive, negative. This is positive. This is negative, right? So you'll write minus I2 into 2. No problem. Now positive polarity of cell is there and current is coming out of negative, right? So current is entering into positive and coming out of negative. So you'll write -5. Okay. And finally, it is written there 50. So that will be equal to -50. Okay. Yes. Got it? है ना? Means from x1, if you will decrease this and this, you will get this. So finally, let us solve this. What you are getting? X minus 5 plus 50 divide by 2. This is I2. So it is same as we have written in the diagram, right? That's all. Very good. You'll solve this all. You'll get the final answer. Potential of point A, that is X, and that is minus 5 by 3 watt. That's all. Okay. Yes, my dear. Next question in front of you is like this. Find the current in the circuit. Find the current in the circuit. I am giving you four options. I am giving you four options, my dear. Find the current in the circuit. A, B, C, D. Okay. Yes. First option 5 ampere. Second option 2.5 ampere. Third option 3.5 ampere. And last option 4.5 ampere. Which of the following is the correct answer? Find the current in the circuit. A, B, C, D. Which of the following is the correct? Yes. Yes, you will do it by your own, my dear. That's why I have raised the options. Come on, solve it fast. Okay. Anyhow, these easy questions you can solve, but I am giving this easy question because you can learn KVL KCL properly. Okay. So yeah, here directly KVL you can apply. Start from any one point and solve it. Come on. A, B, C, D. Which of the following is the correct answer? Find the current in the circuit. Just waiting for your answers, my dear. Very good, very good, very good. Okay, Rajni gave the answer. Very good. Hetvi, now waiting for your answer. Come on, come on, come on. Yes. So now I am just representing, you know. At first you consider direction of current you want. Okay. So I am considering the current is anti-clockwise. I am considering like this. Current I is going like this. You know. If current I is going like this, then current will enter here. This is positive, this is negative. This cell is small plate negative, this is positive, this is positive, this is negative, positive, negative, positive, negative, negative, positive, positive, negative. How I decided the sign across resistance? The point where current enters, that is positive plate, and the that is positive terminal, and the point from where current comes out, that will be negative terminal. Okay, across the resistance. Very good. 2.5 ampere is the correct answer. Huh. Now you choose any one direction, any one direction. So I am considering the same direction of current for my observation. So that is anti-clockwise. That is anti-clockwise. Okay, so let us solve it. Choose any point, start from any point. It's your choice. So I am starting. I am starting from this point. Okay, from this point, yellow point. So I am saying from positive, negative. So I will write negative is the second terminal. So minus 3i, no problem. Come here, positive, sorry, negative, positive. Second plate is positive now. So here you will write plus 30. Come here, positive, negative, second terminal is negative. So minus 2i. Come here, plus minus 15 volt you will write. Okay. Next, come to 1 ohm resistance. So entering from plus and coming out of negative. So you'll write minus 1 and minus 1 into I. Next, come here. So from entering from minus, coming out of positive. So plus 20. Then minus 4I is equals to, yeah, 10 is remaining. So here you will get minus 10 volt. Why? Because first plate is positive, second is negative, right? In this direction, in anti-clockwise direction. Okay. So finally, what you are getting, my dear? Just add this all and solve it. What you are getting? I is equals to 2.5. 2.5 ampere. That's all. This is the answer. Okay, okay, okay. Did you get it? Very simple method I have explained you, my dear. At first, you consider the current flow, direction of current flow. You have observed, okay? Across the resistance, the point where current is entering, that is positive terminal. The point where current is coming out, that is negative terminal. And battery, small plate is negative, big plate is positive always. Okay. Now you consider a direction of observation. You can take it anti-clockwise or clockwise, it's your choice. So I have taken the same direction of current, right, for my observation. So same direction of current I am taking. So I am moving like this, positive, negative. So minus IR negative, because second terminal, sign of second terminal always we will add up. So it will never create any confusion for us. That's all, my dear. We have solved it. Over. Next, find the current in each wire applying only Kirchhoff's voltage law. My dear, you can apply junction also, but use Kirchhoff's voltage law and find the answer. Current in each wire you need to find. Okay, right? Yeah. So IFE you find, IEO you find, and next IBE you find. These all things you need to find. Okay, these all three currents. You know? So I hope you can solve this. Okay. So you solve simultaneously. I am also solving. Okay. You solve it. I am also solving it simultaneously. Come on. Obviously, it may be little lengthy, but you can solve it. Okay. It will take some practice. Means you need to practice it. Then you can solve it within 1 minute also. Okay. Yes. So now I am writing here. I don't know what is the direction of current, but I know key. Let's say this is point E. This is point E. Okay. And I am saying key current in the first loop is flowing like this. Let's say in this current is like this. Okay, so here current is like this. I'm saying the current flowing in this branch, that is like this, and it is let's say it is I1. It is I1. I have considered. Now current in the second branch, here you consider current is always coming out of this E point. It's your choice where you are considering. It is your choice. So I am considering the current here is like this. So this is I2. It's your choice. Okay, again I am saying it's your choice. Now the current will flow like this, and yeah. Okay, so I can say here in this branch current will be what? I1 and I2 both are coming and entering from P point. So you will say current in this point is I1 plus I2. Okay, right? So now you solve it. Now you can solve it easy. Okay. We have considered direction of observation like this. Direction of current also we have considered same as direction of observation. Now choose the positive and negative terminals. I will say if this will be always positive, this will be negative. Current is entering here positive, this is negative, no problem. This is negative, this is positive, no problem. Here current is entering here positive, this is negative, no problem. Come here. Here current is entering across 2 ohm and coming out here, this is negative. That's all. Now easily you can write two equations and solve it, right? So I am writing here for first law. Let's say this is first loop and this is second loop. Okay. So for first loop we can write what? Start from point A. Start from point E. You know, I'm starting from point E. So point E, I'm moving. Second plate is negative, so minus 10 volt. Okay. Here you will write minus I2 minus I2 into 1. No problem. Now come here. You know this middle branch. So here is 30 volt, and that will be second plate is positive. So plus 30 volt. Okay. Now enter into 2 ohm resistance. So first terminal is positive, second is negative. So we always add up the second sign of our observation. Second sign, second terminal sign. Okay. So minus 20, and current flowing through this is I1 plus I2. So I1 plus I2, and sum of this all should be what? 0. And now we have completed entire loop. We have completed entire loop. Okay. Finally, what you are getting? So let us simplify this. Let us simplify this. So I can write here this is minus 10, this is plus 30. So you are getting plus 20. Okay, this is plus 20 minus I2. है ना? Here minus I2 and here minus 20 I. Just a minute, I have written something wrong. Current 2. This is 2. This is not 20. Sorry, this is 2 ohm. है ना? This is 2 ohm. So 2 I2. This is also negative. So you can write here what? This is positive, and here you can write minus 3 I2. And here you can write what? Only minus 2 I1. Okay, so simplify this, you are getting 2 I1 plus 3 I2 is equals to 20. Yeah, first equation you got. Now observe the second loop. Observe the second loop. You are observing second loop. So start from point E. So from E you are starting in the direction of current. This is the observation. Okay. So first the plate you can see what key, small plate negative and second plate is positive. So plus 50 you will write. Okay. Now come here, plus minus. Second is negative sign. So minus I1 into 2. No problem. Now come here. So this is middle branch. है ना? Middle branch. So here you will write plus 30 volt because second plate is positive. And now minus 2 into I. Here you will write I1 plus I2. That's all. Is equals to 0. If you solve this, what you are going to get? What you are going to get? Minus 2 I1. So you are getting minus 4 I1. Then minus 2 I2. And 50 and 3 80. So you are getting plus 80 is equals to 0. If you solve this, what you are getting? You are getting 2I1 plus I2 is equals to 40. Equation number 2. If you solve equation number 1, this equation, and equation number 2, two variables, two equation, solve this both equation and just subtract 2 minus 1. And you write 2 minus 1, you will get the value of I2. Then you will get the value of I1 also. Okay, right? Are you getting? So you'll get the answer, right? You'll get the answer. So current, are you getting, my dear friends? Yes. Current I1. I1 is coming 25 ampere. I1 is coming 25 ampere. Okay. In the same direction as we have considered. Now let us consider. Now let us talk about I2. I2 means in this branch, right? So I2 you are getting what? I2 you are getting 10 ampere actually. You are getting what? 10 ampere. But in which direction? So in the direction just opposite we have considered, actually minus you will get. Okay. Anyhow, which sign you will get? So I2. In second branch current is what? That is 10. 10 ampere. Okay, my dear. But it is in opposite sign whatever we have considered. Okay. And in the middle branch, just difference of that. So you'll get 10, 15 minus 10, 15, sorry, 25 minus 10, you'll get 15 ampere. Okay. Right. Are you getting? Yes, very good. 25 ampere, 10 ampere, and in middle branch, yeah, you are getting 15 ampere. Okay. Right. I have just written magnitude, but actually you'll get with sign. Okay. Very good. Very good. Yes, nice. I hope you got this. Actually, KVL, KCL is really easy. If you follow my instructions, definitely you will be able to solve very easily. Okay. If you got this, please give thumbs up. Please give thumbs up, my dear. Come on, thumbs up. Yes. So that's all we have done. Now, we can start combination of resistance. Okay. We can start combination of resistance. Right. Very good. So now let us start combination of resistance. This topic, why this topic is introduced if we have KVL, KCL? My dear, you cannot apply always KVL and KCL because it is time taking. You know? It is time taking. So, hi Soumya. So simply speaking, my dear, to make the concepts easy, to solve the circuit easily, we have developed another method, that is combination of resistance. Okay, my dear. So combination of resistances are of two types. Okay, combination of resistances are of two types. One is called series resistance and another is called parallel resistance. Okay, so let us talk about the first, right? The number of resistances which are added in a circuit. Okay, so how the resistances are added in the circuit? Yeah, Firoj Parveen. Sir, five means, my dear. Yes, my dear. So, my dear friend, yeah, we are solving a combination of resistances. So, I am saying ki how the resistances are added in the circuit. Based on that, we'll consider a single resistance in the circuit. In a circuit, we'll consider in a particular branch, we will consider a single resistance. Okay, that is called equivalent resistance. Okay, 5 ampere. Oh no, 5 ampere for what, my dear? We have solved this all. Okay, 25 minus 10 and 15 15 we are getting. Okay, so my dear, let us talk about combination of resistances. So now, as I told, my dear, the combination of resistance is really easy topic, right? So first, Resistance in series. So I am taking resistance in series. What is the meaning of that? Its meaning is whenever resistances are added end to end. Means let's say this is first resistance, okay. This is second resistance, okay. And this is third resistance. Resistances are represented by this symbol. All of you know that. Now I am adding this all in a circuit. So I'll just add this end to end, end to end in the same branch. So this R1, R2 and R3, this is called series resistance, okay. So always let's say current is flowing like this. I will say here will be plus, here minus, here plus, here minus, here plus, here minus, okay, right. So this is called series resistance. So in series resistance, current in all resistance will be same, okay. Yes, my dear. So Firoja, my dear, current 5 ampere, it was not the answer in any question, my dear. No problem. You check again, okay. So, series resistance, I hope you got this. In series resistance, what will happen? Resistances are connected end to end, and current in all resistance will be same. Current in all resistance will be same. That's all. That only I wanted to say. Now, how to find potential difference across each resistance? Apart from that, the equivalent resistance of the circuit. So, let's say this is the circuit shown in front of you, and I want to draw a circuit like this. Means I just want to represent this all four resistance as a single resistance. So I will say this resistance is called R equivalent. This resistance is called R equivalent. Why to do that? What is the need? So I am saying let's say current is I. So I is equals to V upon R, means V upon R equivalent. You will get current directly. You will get current directly. Okay. So for series resistance, resistance can be given by R equivalent. R1 plus, R2 plus, R3 plus, R4. Are you getting? So just add the resistances directly. Now how it came? The question is how it came. You know? How it came. Okay. It came from Kirchhoff's voltage law. Okay. And Ohm's law. Ohm's law is always there, right? So I am considering, yeah, in the diagram you can see na yaar. So here plus minus, yeah, the current is shown. Current is coming. First resistance it is entering and coming out. So I will write what? V1 plus, yeah, so you can write what? Listen, my dear. Start from the cell. Let's say this is cell. First resistance is like this, second is like this, third is like this, and fourth is like this. This is plus, current is flowing like this. You will say this is plus, minus, plus, minus, plus, minus, plus, minus. You know? Voltage drop across it is V1, across this is V2, across this is V3, across this is V4. I am just giving you derivation, my dear. Derivation. Okay. Yeah, just move in the direction. So you will write V, no problem. Cell is V, you know, from positive terminal. Now move in this direction. Now you can see V1 is there, but second plate is negative. So minus V1, minus V2, minus V3, minus V4 is equals to 0. So you can see V is equals to V1 plus V2 plus V3 plus V4. You are getting like this. Means you can say in the series resistance, the total potential है ना, is equal to the sum of potential drop of across all cells. Sum of potential drop across all cells. Okay, remember that. Now the next thing, using voltage law, Kirchhoff's voltage law, what we can write? Loop law we can say. So V minus I into R1 minus I into R2 minus I into R3 minus I into R4 is equals to 0. Okay. Can I write it like this? Okay. So finally I'll get what? This thing not needed. And now I am writing its equivalent. No? So I can write it like this. I is equals to V upon R1 plus R2 plus R3 plus R4. Right? R1 plus R2 plus R3 plus R4. I am erasing this all. I am erasing this all, my dear. So I am saying now, my dear, listen. I is equals to V upon you are getting R1 plus R2 plus R3 plus R4. Okay, no problem. I already told you it is equivalent, R equivalent, and this is cell B. Current is I. So you can directly say I have considered a single cell. You know? So I can write I is equals to V upon R equivalent, and that can be given by V upon R1 plus R2 plus R3 plus R4. So finally you can say R equivalent is equals to R1 plus R2 plus R3 plus R4. Simply speaking, my dear, using KVL we can derive this. Okay. Okay. Skip the derivation, not required. Okay, my dear, I'll not repeat and I will not explain the derivation now. Okay, so finally what you are getting? You are getting equivalent resistance, that is sum of all resistances in series. Now, question in front of you. Find the current in the circuit. Find the current in the circuit first. Find the current. So I am giving you option A, B, C, D. Come on, choose the correct answer. Okay, 10 ampere, 5 ampere. Are you getting? Right. Next, 15 ampere. And finally 30 ampere. Which of the following is the correct answer? Okay. Yes, Hetvi Rajni, I will not explain the derivation. Let us move quickly. Yes, answer is B. Very good. So B is the correct answer. Hai na? I can say 30 divided by total resistance 6, 5 ampere is the answer. That's all. Very good. Next, the question is, what is the potential drop across 1 ohm, 2 ohm and 3 ohm resistance? Come on, give me in the same order. Write in the chat. Write in the chat what is the V1, V2, V3 potential drop across each V1, V2 and V3. These things you need to find. Come on, find it fast. Go on. We can write V1 is equals to I into R1. This is I into R2. This is I into R3. So you can write here 5, 10 and 15. You are getting this results. Over. Correct. Very good. Next, bulb. My dear, bulb is also important thing. Anyhow, I explained to you once what is the rating of the bulb, but still I have to repeat it again. Its reason I'll explain. Listen. Let's say this is a bulb. Okay. I am saying its rating. Its rating is given like this. Rating is given like this. 100 watt at 220 volt. What is the meaning of that? What is the meaning of that? So I already told you. Its meaning is when the bulb is operated, yeah, bulb is used at 220 volt. 220 volt, it consumes 100 watt power. Okay, it consumes 100 watt power. Okay, so this is the meaning of this rating. Okay, why the ratings are given on the bulb? This rating on the bulbs are given because we can find the resistance of bulb using this rating. So we can find resistance of the bulb using this rating. So we all know this is 100 watt is power of the bulb at 220 volt. So we can write P is equals to V square upon R. So you can write here R is equals to V square upon P. Okay, now what to write? V square means 220 into 220 divided by 100 watt. Okay, now cancel this. You are getting 484. 484 ohm. So simply speaking, I mean to say is you can find the resistance of the bulb using the rating of the bulb. Okay, right, right. Are you getting? If you got it, please give thumbs up. Please give thumbs up. Yes. So that's all, my dear friends. That's all I wanted to explain you. Let's move ahead. Let's move ahead. So I'm erasing this all. Now one question is there for you. One question is there for you. Yes. Yeah, a buffer came, my dear, because net is fluctuating sometime, right? Net is fluctuating sometime. That's why it happened. But it is not a, yeah. It's okay. So let's move ahead. Question. I am saying rating. Rating of a bulb is given 200 watt at 100 volt. At 100 volt, its power consumed is 200 watt. Find resistance. Find resistance. Come on. First question. Find resistance of the bulb. Come on. Find it. Yes. I'm waiting for your answer in the chat. So you can find here the resistance of the bulb, right? You can say rating is given means P is 200 watt. In that situation, you will say key voltage is 100 volt and R will be V square upon P. So you will get what? You'll get 400 ohm. Are you getting V square? Yeah, sorry, V square upon P, V square upon P. So you are getting 100 into 100 divided by 400. Very good. Divide by 400. If you solve this, what you'll get? This is 200, not 400. Sorry. Yeah. So 50 ohm only. You got 50 ohm. Okay. Now, question number 2 for the same. Question number 2. If the same bulb is operated, if the same bulb is operated at 50 volt, then find power consumed. Then find power consumed. Come on. Find power consumed by the bulb. If it is operated at 50 volt. Come on, come on, come on. Waiting for your answers. Find the power consumed by the bulb. It is operated at 50 volt. Very good. Okay, Rajni gave the answer. So I will say what P is equals to V square upon R. No problem. V square is 50 into 50 divided by 50. You are getting 50 watt. That's all. This is the answer. Very good. Over. Very nice. Very nice. Now, one more important thing. Listen. Listen, my dear friends. So, yeah. So, I am telling you one important thing. Listen. Let's say I am using a bulb here at 100 watt. 100 volt, and this is, let's say, R is equals to, let's say, this is 50 ohm. Okay. So, this is, let's say, a bulb. Okay. Now, I am going to use the two bulbs like this. Same type of bulbs. This is also having resistance 50 ohm. This is also having resistance 50 ohm. Okay. Yeah. In which situation the bulb, in which situation the bulb will have more flash, means more bright bulb. Okay. I'm Rinal. So in which condition the bulb will give the more light, like more intensity of light you will get. First, in first you will say current is I and I is equals to V upon R. So you can say 100 divided by 50, you are getting 2 ampere. Hai na? Or you can write it, this is current and you want to find power. So you can write power consumed is like this. V square upon R also you can write. Hai na? V square upon R. So 100 into 100 divided by 50. So you are getting 200 watt. Okay. Now in second case, 50 plus 50 both are in series, so 100 ohm. You are getting 100 ohm. So current, how much current will be there? So current you need to find 100 by 100, and that is just 100 by 100. Sorry, this is 2 ampere. No? Sorry. 100 by 100, that is just 1 ampere. Okay. Now what is the power consumed? So you can write V square upon R equivalent. You can write no problem. Hai na? Or you can write I square. You can write I square into R1. Power consumed by first bulb. This is first. This is second. So I square into R1. So 1 into R1 is 50. So it will consume only 50 watt power. And second bulb is consuming also 50 watt power. Simply, my dear, the bulb. I'm Rinal. Yeah, so the bulb which is having more, like, which is consuming more power, that will give more brightness. Which is consuming less power, less current is flowing through it, that will give you less brightness. Okay, remember that. Next thing, my dear, listen. If if power consumed by the bulb is more than rated power, है ना? Power consumed by the bulb is more than rated power, in that situation the bulb will be, it will be destroyed, right? It will be destroyed. It will be, we can say it will be short circuited, we can say it will be fused, है ना? So bulb will fuse if it will consume more power than the rated power. Okay. Yes. Very good. So that's all. I have explained you the bulb, and remember this. Okay, my dear. So that's all. So now let us talk about this. There are three bulbs. Three bulbs. First is rated 200 volt 50 watt. Second is 200 volt 100 watt. Third is 200 volt 25 watt. Okay. And now you need to find current through each bulb. Which bulb will give more light? Come on. Which bulb will give you more light? Give me the answer. Mrinal, you are asking what about mirror combination? Okay. Mirror combination is in optics, no, Mrinal? It is in optics, right? That is in geometrical optics, right? Yeah, B2 will give more light as said by Khushi. Okay. Mrinal, I have taken a special lecture on this complete geometrical optics. Okay. Yeah, so you can watch it. Sir, in circuit, why? Okay. Mirror combination. Okay, I think you are saying parallel combination. And parallel. Yeah, it will come now. Don't worry. It is not mirror, it is parallel, right? I don't know why you have written mirror. Oh, Hetvi, you told that. Okay, very good. Nice, nice, nice. Hetvi and Kushi, both of you. Very good, my dear. Now, three bulb. This Rajni Chopra is Kushi, okay? Yeah. So 200 volt and 50 watt. Now 200 watt, 100 watt, and this are given. I can do one thing. I can do one thing. I have connected this all three bulbs in a series with 200 volts. So at first I need to find resistance R1. R1 will be what? 200 into 200 P square upon R. So V square upon P. You know? So divide by 50. So you are getting what? 800 ohm. Okay. Next R2. R2 you are getting what? 200 into 200 divided by 100. Okay. You are getting 400 ohm. No problem. Okay, like complex circuit. No problem, my dear. We'll do many things. Okay, Nanal will do many things. Don't worry about that. But now let's move. Let us move with the basics, right? Yeah. R3, third one. 200 into 200 divided by 25. You know, right? So you can write it is 1600. 1600 ohm. Okay. Now all three bulbs are connected in series. All three bulbs are connected in series. So I will say whatever current will flow, we don't know. Whatever current will flow, that current will flow, that is I. I current will flow through all the three bulbs. You know, same current because they are in series. Okay. I know R3 is greater than R2 is greater than R1. And I know another thing, power P is I square into R. Power consumed by first resistance is I square R1, by second is I square R2, third is I square R3. So I will say P1 is greater than P2 is greater than P3. The bulb which is consuming more power. Sorry. I have written just opposite. P3, P2 and P1. Now it is correct. Now it is correct. Okay. Yeah. So the bulb which is consuming more power will give more light. Yeah. So are you getting? Yes. This is B1, this is B2, and this is B3. So which one will give more light? Okay. Simply speaking, the bulb which is consuming more power will give you more light. Hey guys, why all of you have given second bulb, my dear? Why all of you have given the answer second bulb? Third will be. Come on, come on, come on. Come on, give me answer. Bulb number 3. Very good. So bulb number 3 is having more resistance. It will consume more power. Okay. Yes. Are you getting? We have done with this. Okay. So now, yeah, if we wanna check, you know, yes, due to maximum power consumption, bulb number 3 is correct. Very good. Very good. Okay, my dear friends. Huh. Tell me what is the power consumed by the first bulb? What is the power consumed by the first bulb? Oh, you took result on the rated power. No, my dear. You can see here in circuit 200 volt battery is connected. No, my dear. you have to take according to that. Okay, you have to take according to that bulb. Sorry, according to that cell. Cell is 200 volt. Okay. Yes. So in the circuit, it is what power it is consuming. So 200 volt cell is there. According to that, we have to see. Okay. Oh my dear, just a minute, just a minute. I have written something wrong, my dear. I have written something wrong. And your answer is correct. Bulb 3 will be the brightest, but I have written something wrong here. Listen, what's wrong I have written? Yes, R1. R1 we got 800 ohm. R2 we got 400 ohm. And R3. R3 we got 1600 ohm. Now I have written the wrong order, sorry. R3 is greatest, after that R1 and last is R2. Yes, this is the least. So simply power will be P3 will be greatest, then P1 and last is P2. Right? This is the order. Right? But question is which bulb will give more light? So bulb 3 will give the more light. Okay. So answer was correct, only bulb number 3. Okay. Right. Okay, okay. Rajni, all of you, did you get it, my dear? In the last, I have just written the wrong order. Answer is correct only. Last time also answer was correct, but I have written the wrong order. Now I have written the correct order. Okay. Yes. So that's all. It's over. Now let's move to the next slide. Resistance in parallel circuit. है ना? Resistance in parallel means the resistance are connected in a circuit in such a way that potential difference across each resistance is same. Potential difference across each resistance is same. Then it is called parallel resistance. So you can see it will be like this. You know? Let's say this is A terminal, this is B terminal. Here is one resistance, here is another resistance, here is another resistance, and here is one more resistance. These all are called parallel resistance. Okay. So in parallel, as you told, I should not explain the derivation, so I will not explain definitely. Okay. Yeah. Remember one thing, potential drop across each cell will be same. You know? So I will say VR1 that will be V, VR2 that will be V, VR3 that will be V. Okay. Now you want to find current in first one. Current in first one. I1. So I1 will be equal to what? V upon R1. I2 will be equal to what? V upon R2. I3 will be equal to what? V upon R3. And what is the total current coming out of the cell? Total current coming out of the cell. So I will say this is cell. From here current is coming out I and it is dividing into three parts. I1, I2, I3. So you will say I will be equal to I1 plus I2 plus I3. No problem. So total current what you will write? V upon R1 plus V upon R2 plus V upon R3. है ना? Like that you can write anyhow. Yeah. So equivalent resistance 1 upon R equivalent can be written as 1 upon R1 plus 1 upon R2, 1 upon R3, so on. Right? That's all, my dear friends. So in that situation, the current coming out of the cell will be equal to sum of current of all the branches. है ना? Next, each and every resistance will have same potential difference across it. If resistance is more, power is more. Yes, my dear. HP. Listen, listen, listen. One important thing. If resistances are connected in series, in that situation from all three bulbs are connected in series, then in that situation, current through all three bulbs will be same. Okay. Now we will say key which bulb is consuming more power. So I square into R. I square into R. So I will say more resistance, more power consumed. More power consumed means it will glow more. That's all. Okay, my dear. So that's all. It's over. So you can find this. That's all, my dear friends. How to find I1, how to find I2, how to find I3, all three currents also you can find. So I hope you got this. I hope you got this, you know. Now one shortcut, my dear. Just shortcut you remember. If only two resistances are there, what you will do? What you will do? Let's say this is V. This is R1. This is R2. So you will directly say what? R equivalent is equals to R1 R2 divided by R1 plus R2. Remember this short trick and a short formula you can say. I will be equal to what? V upon R equivalent. You will get the current. Now what is the current through first resistance? What will be the current through first resistance? So you can find like this also. I1 is equals to V upon R1. Current through second resistance I2 is equals to V upon R2. You can find. No problem at all. Okay. Yeah. You can find it like this also. Resistance more, current will be less. Okay. So I will be equal to, here you will write what? I1 is equals to, you will write I R2 upon R1 plus R2. It is just in opposite order. I2 is equals to I R1 upon R1 plus R2. So this is another formula, right? I think you might be knowing about these formulas. You just need to remember, that's all. Okay, right? So just I am erasing this. Anyhow, questions will come. You will automatically understand these all things, right? That's all. So let's move ahead. Question is there in front of you. Find the current passing through the battery and each resistance. At first, current through battery you find. Current through battery. Come on. I am waiting for your answer. A, B, C, D. Four options are there for you. Okay. This is question number 8. 8. Yeah. Current through the battery. Find it first. Which of the following is the correct answer? Find the current through the battery. Very good, Kushi. Hetvi, very good. Very nice. So here C option is the correct answer and very good. So nice. All of you have given the correct answer. Simply speaking, you can solve it directly like 1 by R equivalent is equals to 1 by 2 plus 1 by 3 plus 1 by 6. LCM of this is 6 and here you will write what 3 plus 2 plus 1, 6 by 6 is 1. And so 1 by R is 1, so you will say R equivalent is equals to 1 and I is equals to V upon R equivalent, means 30 by 1 is equals to 30 ampere. That's all. This is the current through the battery. Now current through the each resistance. What will be that? So you'll take if first one is having I1. I1 is V upon R1, means 30 divided by 2. I2 will be V divided by R2, means 30 divided by 3. R3, so you will say what? 30 divided by 6. So directly you are getting what here? 15 ampere, 10 ampere and 5 ampere. That's all. So these are the answers. Right? Sum of this all is 30 only. Very good. Very nice. Let's move ahead, my dear. Let's move ahead. Question number 9 in front of you. But here it is given internal resistance. It is given internal resistance. So series is there. Along with that, parallel is also. Hai na? Means parallel are there and series are there. Right? Yes. So you need to find the current passing through the battery. Come on. Current through the battery you find first. Come on. You can do it. Current through the battery. Waiting for your answers. Internal resistance is given. 1 ohm is the internal resistance. Come on, find the current through the battery. Same question, but internal resistance is added. Very good, Kushi. Hetvi, very good. Very nice. Very nice. I am impressed with you all. So, my dear, we can say that this resistance, this is 1 ohm only. Its equivalent we found in the last question. And here is also 1 ohm internal resistance. This is 30 ohms. So I will say I is equals to, these both are in same circuit, right? Means these are in series. So simply you will say what? I is equals to V upon R. V is 30 volt and this is 1 ohm. 1 plus 1, 2 ohm. So you'll say 15 ampere is the total current coming out of the battery. Now, current passing through 2 ohm, current passing through 3 ohm and current passing through 6 ohm. Come on, I1, I2, I3. Tell me that. Current passing through each resistance also tell me. Go on, tell me current passing through each resistance. You can do it. Come on. I'm waiting for your answers. What is the current passing through each resistance? And I1 means current passing through 2 ohm. I2 current passing through 3 ohm. I3 current passing through 6 ohm. You know? Come on, do it fast. Waiting for your answers. 7.55, 2.5. Okay, very good. So now I'm solving it, my dear friends. Listen. How I can solve. Listen. know one thing, this is 30-volt battery, and current we got the current. Current we got 30 by 2 means 15, we are getting 15. 15 ampere is the total current passing through this branch. Okay. So here also current I is 15 ampere. है ना? Now what will happen here? This resistance will consume how much? Resistance will consume V is equals to IR. I means 15 into R means 1. So you will get minus 15 volt. So my dear, total 30 volt is given by the cell and 15 volt is consumed by this internal resistance. You know? Internal resistance is consuming 15 volt. So just the voltage left across this three parallel resistance, that is only 15 volt. 30 minus 15 is 15 volt. You know? So just you can solve directly. Very good. You can write what? E. This internal resistance 15 volt I into R. So 15 volt it consumed. Now for this three resistance, you know, for this three resistance we are having only and only 15 volt, you know, 15 volt. So across this we are having potential difference only 15 volt. That's all. So this is 2, this is 3, this is 6. I1 is equals to 15 by 2, 7.5. Very good. I2 is equals to 15 by 3, that is 5 ampere. Very good. And third, I3 is equals to 15 by 6, that is 2.5 ampere. Very good. Over. Very nice, my dear friends. Very, very good. Next question is there in front of you. Find the equivalent resistance of the circuit. Find the equivalent resistance of the circuit. Come on. You can see it is short circuited. I told you what is short circuit. I told you in the last previous classes. Here, this circuit is short circuited. You need to find the equivalent resistance between A and B. Find the equivalent resistance between A and B terminals. Come on, my dear. Answer fast. Waiting for your answers. Okay. That we have given just like reciprocal of answer, right? उल्टा आंसर लिख लिया आपने. सीधा करो उसको. Yeah, simply speaking, this is point A. So this is point A. Okay. Now this is short circuited. So this is wire having no resistance. So this point is also point A. This point is also point A. No problem. I have written here point A. Now this point is point B. Now let's move along this wire having no resistance. So this is also point B. Okay. I can see here each resistance is having A and B terminals. A and B terminals. So how to write? Let's just draw 2 points A and B. So this is A point. This is B point. Okay. Now draw all three resistances. So I am drawing this one first. It is between A and B. So between A and B I have drawn. This is R. Now draw this second. First we have done. Now draw the second one. This one. So here is A and here is B. So it is also between A and B. So I am drawing here A and B. Okay. And third resistance you can see here is A and here is B. So third resistance is also having two terminals A and B. So same it will be like this. All three are in parallel, right? So you will write 1 upon R equivalent is equals to 1 by R plus 1 by R plus 1 by R. And so you can write what R equivalent is equals to R by 3, right? Are you getting? So 1 by R plus 1 by R plus 1 by R means R by 3. It's the correct answer. That's all. Very good, my dear. Next question in front of you. Come on, find the equivalent resistance between A and B. Find the equivalent resistance between A and B. First question, find equivalent resistance between A and B. This is the first question I am asking. Find R equivalent. Come on. Come on, my dear, you can do it. Hi, Himanshu. How are you? Yes. Waiting for equivalent resistance. Hetvi, I'll explain that. Don't worry. Hetvi, how to apply KVL, KCL using capacitor and all, I'll explain that. Don't worry. That after teaching capacitor, I'll teach those circuits in which we'll use capacitor resistance for all things. Okay? Don't worry. I'll teach you everything. Have patience. Have patience. Okay? Come on, my dear. So for this, what will be RAB, equivalent resistance between A and B? So simply I'll do one thing. Just mark the short circuited point. So I'll write. I know this is point B. Okay, it is short circuited here, so this is also point B. No problem. This is point A, but you can see here is resistance. So now no other point will be A point. So I will say this is some different point. C point. This will be C point. Are you getting? Yeah. So I have A, B, and C point. That's all. So these are the points I am having. Now what to do? Now what to do? So just solve it. So I am saying, let's say there is A point, there is B point. Now how many resistances are there between A and B? So this first resistance, this is between A and B. So just draw it directly without any problem. So A and B, this is first resistance I have drawn. Now no any other resistance is there between A and B, but you can see this resistance is between B and C. This resistance is between B and C, and this resistance is also between B and C. So there are two resistances between B and C. Okay, right? And one is between A and C. So I am drawing a point C here. This is point C. So one resistance is connected with A and C. I have drawn like this, and two resistances are between B and C. So I am drawing two resistances between B and C. That's all. So these are two resistances between B and C, right? That's all. So you can see this is R. So directly you can say key equivalent of these two is R by 2. Now this R and R by 2, it will form such type of circuit. This is R and this is R by 2 and this is R. Okay. So these two are in series and this is in parallel. So I will write here. I'll write here 3R by 2 and here is R. Correct? Right. Now again take its equivalent. So these are in parallel, right? So you will write R equivalent is equals to 3R by 2 into R divided by 3R by 2 plus R. So you are getting 3R by 5. That's all. This is the answer. Very good, Kushi. Your answer is correct. Yes. So 3R by 5 is correct. Himanshu, you are correct. Hetvi is correct. All of you are correct. Very nice. Very nice. So this is the simplest method to solve it. Okay. Another method also you can follow. But if you will solve like this will be better for you, right? So we have done. Let's move ahead. Yeah, this is the question in front of you. Find the current through 2 ohm resistance. Find the current through 2 ohm resistance. This is a good question. This is a good question. Come on, answer fast. Find the current through 2 ohm resistance. Four options are there. First, 12 ampere. Next, 3 ampere, 2 ampere, 8 by 3 ampere. Which of the following is the correct answer? Sorry, here I need to write 2 by 3 ampere. Yeah. Which of the following is the correct answer? Go on. Find the answer. Correct answer. Current passing through 2 ohm. Current passing through 2 ohm resistance. Go on. Find it fast. Yes. Come on. Come on. Come on. It's a good question, right? Okay, very, very good. D option, you are giving the answer. Very nice. It is correct. D option is the correct answer. Very, very good. Amazing, Kushi. You are so fast. I liked it. Similarly, yeah, Kushi, similarly, you have to perform in mechanics also, okay? In projectile motion and all chapters also, you need to perform similarly, okay? Yes, my dear Himanshu, very good, my dear. You are also correct. So how to solve it? So I am solving in a easiest way, है ना? First, these two are in series, है ना? So I am drawing in a detail, my dear friends. Let me solve it in detail, right? Yes. So I'll say ki here. Here is 4 ohm. This is 6 ohm, and now this 2 will be simplified, so you'll get a simplified resistance like this. So 2 plus 1 is 3. This is 6. You know? Now these two are in parallel. So let us solve these two. These two are in parallel. So 6 into 3 divided by 6 plus 3. Equivalent of this will be 18 by 9 means 2 ohm. So now let us solve. So the next circuit will be like this. All things remain same. But here you are getting equivalent, and that you are getting what? 6 into 3 divided by 6 plus 3, so you are getting 2 ohm. You know? This is 3 ohm and this is 4 ohm. You can see 2 and 4 are in, these are in parallel. So you can write directly here. You can write directly here like this. One resistance. This is second resistance. This is resistance. And now 6 and, yeah, so this is 6. This is 6. This is 3. Yeah, further you can solve it. So finally you'll get what? You'll get this one is 4 ohm. This one 6 into 3, 3 plus 6 means 2 ohm. And this one you are getting 4 ohm. And battery is of 12 volt. Battery is of 12 volt. Sorry, 120 volt. Yes, directly you are getting total current from the battery. That is what? Total resistance. So 120 divided by total resistance is 10. So you are getting 12 ampere. You are getting 12 ampere. No problem. Right? Yes, my dear. Yeah. So you got the total current coming out of the battery. Now you need to find the current passing through. Current passing through this, yeah, this branch. Which branch? You can see 2 ohm and 1 ohm. You know? So from this branch, how much current is passing? So we have a simple method equivalent of this. We can see here. This is 6. You know? This is 6, you can say, and this is 3. So from 6, how much current is passing? So I will say current will divide in a ratio of what? 1 is to 2. है ना? So from 6 ohm 1 and from 3 ohm 2. है ना? This ratio will be, this ratio the current will have. So you will get, say कि current passing through this 6 ohm है ना, from this branch. So that will be equal to, right? What you will write? So you will write what? 1 by 3 into total current. So you are getting 4 ampere. 4 ampere current is passing. So you can say total 4 ampere current is passing. Now it will again divide. It will again divide. You know? It will again divide among two branches. Correct? Yes. Very good. So now this 4 ampere current is divided into this 3 ohm and these two branches, right? So 4 ampere current is going and it is divided into this branch and this branch. How to solve? Again 1 is to 2. So you can say, okay, let us divide this 4 into 2 by 3. So you are getting 8 by 3 ampere. Now, are you getting right? If you got this, give thumbs up. If you did not get, I will solve in detail. I have just solved it in a shortcut, right? I have just used the shortcut. Very good. Yes, my dear. 6 by 9 into 4, that is 8 by 3 ampere. That only I did. 6 by 9 I have written 2 by 3. Hey, 3, if you got it, please give thumbs up. If you did not get, I'll explain again. Okay, very nice. Very good, my dear friends. So that's all. We have solved this. Current passing through this 2 ohm resistance is 8 by 3. What is the current passing through this 6 ohm resistance? So it will be just 4 by 3 ampere. Okay. Yeah. So that's all. We have done. So that's all for today, my dear friends. We have done enough for today. So see you later, my dear friends. I hope you got this and you enjoyed today's lecture. You know, tomorrow again current electricity, my dear friends. Tomorrow again current electricity. Okay. So we'll do further topics. We'll cover further topics tomorrow again. Current electricity. Use my code Rahul D to get the Unacademy subscription. You'll get the 10% discount on Unacademy subscription. If you wanna get Unacademy subscription, get it ASAP within 2 days. Happy tomorrow same. Tomorrow same, my dear. Tomorrow again current electricity only we will take. Okay. Yeah, we'll continue this. So my dear friends, if you want to get an Academy subscription, please use my code Rahul T and get 10% discount on it. And please like the video, if possible promote it as much as possible, okay, because we are getting very less views. Oh Kushi, 15 minutes more are left. Actually, my hours are completed, but I can give you one question. I can give you one question, okay? So I am giving you a question. Yeah, you just solve this question, my dear. Yes. So now I am saying, let's say this cell is of 20 volt, this one is of 5 volt, and let me add one more cell here. It will be better. So I am adding one cell here. This is of 5 volt. Yes. Okay. Now I am giving 5, 5. This is 5. It will create a problem. Let me write here 3. This is also 3 ohm. This is also 3 ohm. This is also 3 ohm. All resistances are of 3 ohm. Okay. Right. Yeah. Find the current. Find the current passing through this 3 ohm resistance. Find the current passing through this 3 ohm resistance. You know? That's all. That's all you need to find. Try this. Find the current passing through this red branch. Come on. Waiting for your answers, my dear. Yes, solve it. So I'm just waiting for your answers. From the 1st November, I will take 2 lectures daily, okay? One will be on the special and one will be on YouTube. Maybe someday if I am not taking special, that day 2 lectures I'll take on YouTube, okay? Yeah. But those will not be of 2 hours lecture. If those will be 2 hours lectures, like I'll be exhausted. Actually, it takes time to make PPT. Yeah, it take enough time to make PPT. That is only the reason. Else we can take the lectures entire day. But the problem is PPT. Making PPT is a big task. Come on, come on, come on. Find the correct through this red branch. Yes. Shall I solve? Shall I solve? You can use KVL. If you want, you can use KCL. It's your wish. Okay. Yes. So now, yes. Hi, Jay Krishna. Hi. So now I am solving this, my dear. Now I am solving this. Okay. Let me draw this small circuit here so that I can solve this in entire page. So I am drawing the circuit again. By the time you solve it, my dear. That's all. So this is 20 volt, this is 5 volt, and this is 5 volt. Okay, no problem. Yes. So now we are going to start. Listen. At first you consider, at first you consider here is a 0 volt. Means I am solving using KCL, current law or loop law. Okay. Yeah. So this is 0 volt. So this is 0 volt, no problem. Here 0, so here it will be 20 volt. Here it will be 20 volt, no problem. So this is 20 volt, and I don't know the potential of this point, so I am considering that is x. That is x. Okay. Now what next you can do? Let us solve this. So 3 and 3 6. 6 is in series, and overall it will make 2 ohm. Overall it will make 2 ohm. You know? Yeah. So if I'll solve this, what I'll get? So simply just we can simplify it. Hai na? Just we can simplify it. So I am solving it at somewhere else. Here let me see anywhere else I am having. Yeah, here I am solving. So simply I can say here is 3 ohm resistance, no problem. Now this is 20 volt, this is 5 volt. Okay, so this is 20 volt, this is 5 volt, and here is also 3 ohm. Now I'll add all the resistance in the third branch. So 3 ohm plus this 3 2 3 6 6 into 3 divided by 6 plus 3, so it will give 2. Hai na? So 3 plus 2 5 5 3 8 ohm. So total 8 ohm. So I can write here the cell is of 5 volt. This is of 5 volt, and here you are getting 8 ohm. That's all. Now it became very easy for you. है ना? Now it became very easy for you. Now let us solve it. How to solve? So just consider current, है ना? Current from this branch, it's your choice. So let us consider current from this. Yeah, it is going, let's say, coming towards this, है ना? I am saying this is V. Here also current coming towards this. Here also current coming towards this. That's all. Okay. So here I can write what? This this is V volt, right? And here I have considered 0, so this is also 0. Here is it is 5 volt. Here it is 5 volt. Okay. Now this is V, this is 5, and here is 0. So I'll say here is it is 5 volt. 5 volt. Okay. I am considering this is current I1, this is I2, and this is I3. So directly you can write I1 plus I2 plus I3 is equals to 0. है ना? Right? So it is just taking some time to draw the diagram, but it is easy. Okay. Now let us solve it. Now let us solve it. So you will say key potential across the resistance divided by R is the current. You know? So you know it is 0. So here is 20. And current is coming towards. So current always flows from high to low potential. So 20 minus V divide by resistance is how much? 20 divided by V, and resistance, this resistance is 3 ohm. So you are writing 3. Now here what you will write? So here current is I3. Hai na? So you can write this is 5 volt across this. Hai na? So 5 divided by 3. Correct? So here you will write what? 0 minus V divide by 0 minus 5 divide by what? Yeah. What can you write here? What can you write, my dear? What can you write here? So this is what? 5 plus V. So sorry, this is potential, here is V. So here you will write 5 plus V. So 0 minus 5 plus V, and here resistance is 3. And last in this last circuit, so plus you will write what? There is a, yeah, here is V, and here you will get 5 plus V volt. What? Here you will get 5 plus V volt. So you will write what? 0 minus 5 plus V divided by 8 is equals to 0. Sum of this all is 0. You will solve it, you will get the answer. Okay, you will get the current. So my dear friends, that's enough. You can solve it easily using KVL. Also you can use it using loop, like Kirchhoff's junction law. Also you can solve it. Okay, my dear, you should know properly how to write it. Okay, either you consider all currents are going away from this junction, or all currents are coming towards the junction. It's your choice, right? So that's all for today, my dear. I have to go now. I have to go. So thank you, my dear friends. Bye bye. So now I would like to say goodbye to you all. Right? Yeah. So you can find the current now. Not a big deal. Right, my dear? आंसर क्या है यार रजनी? आई डोंट नो द आंसर. आई डोंट नो द आंसर. Actually, I did not solve it randomly. I gave because you asked, है ना? So just some more calculation is needed, right? Some more calculation is needed. You can find it easily. Okay? Yeah. So my dear, I have to go now. So I am saying bye bye. You just calculate it. Anyhow, we have solved it, right? Just put the just solve it. You'll get the answer. Okay. So bye bye. Good night. Okay, Khushi. So bye bye, my dear friends. Good night. Take care.